2, that would work, right? But it's not the least. So I think 21 is the smallest you can get if A and B are 3 and 7. Okay. Anyway, theorem 6 states that if that's the case, then the product of these two, AB, is equal to that by that, HL. Now, I don't give the proof. You can try it at home if you want. I mean, I have to leave some of the homework exercises at the end of this chapter to you. I won't solve them all. Right, now the second half, in a sense, of this lecture deals basically with the concept of congruence. I'll explain what it means to say that two integers are congruent. I'll give the definition of that term. And then using this concept of congruency, I'll talk about something called residue classes. So these two are closely linked. Okay. Again, I need to clean the board. Wondering how much longer this board's going to last, because can you see this grey patch that's appearing just through friction? I'm rubbing away the white of the surface, leaving what's underneath. So it's not white all the way through, which is annoying. Okay. Right. So let's start with congruent. Two numbers. So congruent. Let's say. So two integers A and B are congruent by definition if modulo n. I need to specify that. I'll explain what that means. So two integers are said to be congruent, modulo n, if A minus B can be divided by n. Or put it another way, which is the same thing, n divides A minus B. Okay, now, so what? So let's do some examples. Question 3. Now the textbook author uses, now I use 3 bars to mean, by definition. He uses 3 bars to mean is congruent to. So don't be confused, right? There are 2 uses here. So this here means by definition, and this one here means that this number, so I'll put a question mark here, and this is the exercise at the moment. So is 3 congruent to 24 modulo, so we'll just shorten that to mod 7. Okay. So to find the answer, you just so here's your 7. So that's your n, and that's your A, and that's your B. Okay. So you just test whether 7 divides A minus B. Well, so A minus B is 3 minus 24, that's equal to minus 21. Now does 7 divide minus 21? Yes, it does. Therefore, 3 is, using the mod 3 bars of the textbook author, of Barnard. So 3 is congruent to 24 mod 7. That is the case. Okay, now let's quickly do a few others. How about this one? 11. Is it congruent to minus 31 mod 7? Is that true? Okay, so that's A, that's B, that's N. So you just you check whether does N divide A minus B. So so A minus B, that would be 11 minus 31. Well, that's 42. Right? Now 7 does divide into 42. Therefore, so 11 is congruent to minus 31 mod 7. Okay, do one more, so just get the hang of it. Now, true or false? Is 25 not congruent to 12 mod 7? Mod 7? Is that true? That 25 is not congruent to 12 mod 7? Well, so that's your A, that's your B, that's your N. So so 25. So A minus B, 25 minus 12. That's equal what? 13. Now, can you divide 13 by 7? No. Therefore, this is true, right? So that's actually true, right? Right, now theorem 7. Again, same problem. I need to clear the board. What did I do with that? Okay. Okay. Now theorem 7. It's also fairly complicated. You need to think of it. Okay. So A is congruent to B mod n if and only if. So again, we have to do a two-part proof both ways. So it's if and only if A and B have the same remainder or residue. Remainder and residue, same thing. Okay. Have the same remainder. When dividing or on division by n. Okay. So now we've got to do an if and only if type proof. So we have to go both ways, from left to right and from right to left. We've done this several times now. You're probably getting used to it. So let's call this left-hand side statement P, mathematical statement P, that is that A and B are congruent numbers, mod n. Okay, and this we'll call that's statement Q. Okay, so we have to prove P if and only if Q. Right, left hand side if and only if right hand side. Now, as usual, start with the if case, the first half of the first one of two-part problem, two-part proof. Okay, so now the if, so P if Q. That means P is true if Q is true. So if you start with if you start with Q, you know that P is true. Right? P is true if Q is true. But so let's start with Q, so we know P. So if that's like the if Q then P. Right? So so we start with Q. We start with this, and we've got to prove that's the case. All right. So A and B have the same remainder when you divide by n. So let's now knowing that